Okay, now can everybody hear me? Maybe. If you can find the React icon on your menu bar and just hit a thumbs up or something. Yay, thank you, Ronald. I think that you mean that you hear me. Perfect. Welcome to our experiment. We're pretty well versed at webinars right now, but and we were great at in-person. Hybrid is very new for us. Welcome, thank you. We are getting the room all um, set and about ready to start. You have made it to the right place. And let me make sure we've got the room camera on over on the other computer here. Ross, do you mind toggling the on the go to put the room camera on? Oh, I can hear my voice echo in the room. That's weird. Thank you for bearing with us. There, okay. So can everybody see the room camera? Mike is up there, Ross is up there. I see David's head. If you can give me a thumbs up, that would be great, or a whatever react. Okay, I'm going to present the little housekeeping items to our online people right now. And if I can find my mouse, whew, we're in a different room. You guys, if you've been on these webinars with us before, you know something always goes weird. And we've just chosen all of the opportunities today with different room, different setup. Okay, so thank you for coming to our webinar today. If you've not taken a webinar with the Lighting Design Lab, we use GoTo platform. You're on mute the whole time just to keep the webinar running smoothly. However, feel free to ask whatever questions come to you in the questions little icon there. So take a second and look for that. Click on that. A little box will pop up. You'll be able to submit a question. I'll see it and I'll interrupt Mike and he can answer it for you. The webinar is being recorded, so if you have to skip out early or if you want to send this to colleagues later, we'll have this on our website within about a week. Give me about a week. And then there is a survey for those of you who are online that'll pop up in your browser after the webinar closes, and would love for your feedback, especially because today is new for us, and would love to hear how it went for you. Please just erase from your brain those first 3 minutes where I didn't know what I was doing. And then for in-person, thank you everyone for coming out to the college today. So happy to be back to some in-person stuff. If you were ever able to visit the lab facility in Soto, it was such a cool space, and we hope to get back there shortly. But that is the plan. But for in-person today, just so that we can allow the people online to hear your questions, please try to raise your hand before you ask questions so we can get a mic to you. Otherwise, there's a whole lot of I didn't hear the question. Can you repeat it? So just try. I know Mike's very good at conversation, so it might be tough to wait and raise your hand. And then for you folks here, we've got a QR code to the survey online. So scan it now to have it up for later. I'll have it at the end too as a reminder to you. And there are, I think, a lot of new people on this call that don't know what the Lighting Design Lab is. We are a program within Seattle City Light now. Been around for decades. Eric Strandberg is still here if you've ever interacted with him. He's waved over there. It was formed by PPA and Northwest Utilities, so that's who started it. It's now a City Light program. We're all Light employees. But in the past couple of years, we've been, hearing the call for let's do more than lighting. Whole buildings now, we expanded to controls, but now it's everything is connected, and all of the electric uh, um, things. Lost my words. Are important within those buildings. And so we are going to bring experts in like Mike to talk about heat pumps. Um, oh, I'll get the Slido password to you in a second. Um, to get um, building electrification professionals up to speed on all this stuff so that we can meet our climate goals. And we are still called the Lighting Design Lab. We will have a new name shortly to reflect this new expanded territory that we're in. And we have lots of opportunities to engage. My colleague Robert, who'll be up in a second, has done a real stellar job at keeping these moving while we're in transition and trying to develop a sort of a more solid curriculum like you knew if you knew lighting design lab before. So there are some of our upcoming options. One next Thursday. We have another hybrid one on the 29th. That's pretty specific for M&V with BPA utility programs. And then one that I'm just going to open today, it's not ready to register for yet, maybe about 2 o'clock today, on those window saddle mount. Sometimes they're called micro heat pumps. We're going to talk about that technology. And then a couple events for trade allies. Um, One is specific to City Light's Trade Ally program, which just opened up, and one is on controls and commissioning, and that is with PSE, SNOPUD, and Tacoma, and I think it's just the 4 utilities talking about their programs. And Ross, would you like to introduce your slides? This is Russ from the Sustainable Building Science Technology program at South Seattle College. Oops, it automatically went. Are your slides timed, Russ? Okay. I've received messages that the podium mic is not online, so we are working on that really quickly. Thank you for letting us know.
Can the online people hear me speak now?
Let's.
Great. Back to full. Okay.
Oh,
Thank you for the folks online. Just real quick, my name is Ross Baswani from the Sustainable Building Science Technology program here at South Seattle College, and thanks for being here. The SBST program, just a real quick introduction to the SBST program. We're a bachelor's degree designed to build on professional and educational experience of students. The curriculum is designed for students to become highly skilled building science professionals with deep understanding of building functions that are healthier, more efficient, and sustainable. It offers flexible industry relevant curriculum that allows students to advance their careers while continuing to work applying their real world experience in the built environment. Um, uh, the SBST graduates, they earn a degree that are recognized by industry leaders and align with new policy established building performance standards. They are prepared to make an immediate impact, contributing to energy efficient, high performing buildings that meet the growing demands for sustainability and operational excellence in the built environment. We recently celebrated our 10-year anniversary last week. We had over 70 alumni and industry people and college folks here, and it was a lot of fun. And it was just a reminder of what the program has gone over the last 10 years and what we're looking forward to in the future. One of the things that we're celebrating is something that was just awarded, and it was also an opportunity for us to celebrate the new Pacific Northwest Building Training and Assessment Center. This is a partnership with SBST, two programs at UW and the Northwest Indian College. Among the center's aim is training people to improve energy efficiency in small and medium-sized buildings, particularly in historically disadvantaged communities. Funding for the center comes from the U.S. Department of Energy. One of the images that I had was just an example of what our students do. They are working with their paid internships. They're working in the community. They're working with building owners, and so there will be through BTAC. There will be also other opportunities for partnerships. So I just wanted to give a shout out. And with that, I think I'll pass it off to Robert. And again, thanks for everyone being here.
Good morning. On behalf of Seattle City Light and South Seattle College, I'd like to welcome you to this session on net zero and decarbonization. I'm Robert Bogatai of Seattle City Light and work supporting the electrification efforts. In other words, heat pumps are us. But there's more than heat pumps. There's design considerations, shading, airflow, and other things that can improve building performance, and we'll get to hear some of that today. But first, a plug. Part of my job is recruiting speakers for these sessions. So if you have a case study, a technology, or something you'd like to present, let me know. Thank you. Our speaker today is Mike Dieterich, who will talk about design and planning for net zero and accomplishing decarbonization. I met Mike at the Association of Energy Engineers conference in Bellevue. See picture. Now you know I'm one of those guys, and Mike is the other.
Looks like you have wine.
This is true, and I noticed that my glass is fairly full, and Mike's covering up his.
I was using mine as a table.
That was the reception afterwards. Following that, I viewed Mike's TED Talks and other information on the web. Then I learned about some projects Mike has done, and today you will hear some of those too. Mike has a book out called Renew and Sustain. Sorry, I haven't read it yet. He's also presented to groups like the United Nations and the US Congress. With 20 years experience of sustainability, we are glad to have Mike here to talk with and to us. Mike.
Oh, awesome. It's my turn. Sweet. Is that what that's supposed to do? How do we do that? I'll let you do that. Oh, it's up front. Perfect. Awesome. The wonders of technology, huh? Roll our sleeves up a little bit. Move that guy. Can y'all hear me? Can everybody hear me online? Sweet. Yeah, I got thumbs up. That did not. That is going differently. There we go. They already did my introduction, so I'm not going to redo that part. I'll just dig right into it, right? Because there's a lot of stuff to cover today. So I kind of did this decision tree, right? So we're talking about decarbonization or net zero energy for buildings, but those things really go hand in hand. Because as we make a building more efficient, we're also setting it up for a decarbonization strategy. And the biggest thing to start with is we have to know what we have. So it's the assessment. And if you're looking at an ASHRAE Level 2 audit, how many engineers do we have in the room? One. How many architects? What does everybody else do?
Energy management, analyst.
Sweet. Similar?
Lighting, contracting. Resource conservation, CPM.
Awesome. So we have a nice range of folks. So it's like an ASHRAE Level 2 audit really looks at those hard systems, or we're looking at the mechanical aspects. But then how many people have done a DOE treasure hunt or heard of a DOE treasure hunt? It's something kind of similar, but if you've ever walked into a building and you've seen that nice air gap, it's like, oh, wait, we're losing a lot of airflow. So it identifies opportunities like those air gaps, and then it provides a formula for calculating the energy efficiency. On one project, through a DOE treasure hunt, that's why they call them treasure hunts, we found a pinball machine was using $4,000 a year worth of electricity, which is just like crazy on these fun tech campuses, they have pinball machines. But if you put a Christmas tree light timer on it, super affordable, you then can just have it available because it needs to be available for the employees because of the user experience, like when there's operational hours, and somebody could turn it on after hours. But it's super interesting that it identifies those small opportunities too. CHIPS, which is the Collaborative for High Performing Schools, has an operational report card. And so they're also looking at like light levels on a student's desk, or CO2 in the classroom, because students, or even us as adults in an office space, perform less after we reach 1,000 parts per million in an indoor environment. It's not actionable by OSHA until it's above 5,000 parts per million, but there's decreased cognitive abilities once you start escalating. And so you can start to monitor and track these things through these types of assessments, and there's various ways of doing it. And then from those assessments, we end up with opportunities to improve energy efficiency. Sometimes that is also water efficiency and waste efficiency. And then we can upgrade. I think somebody in this room was talking about how ineffective this lighting design is, which is an awesome opportunity to be like, hey, this is old school. This is what was done. This is why they did it that way. This is where we're moving and why. And I think of a building as different systems. So you have your building envelope, which is a system. You have your HVAC, which is a system. Lighting as a system. Plug loads, and then from your plug loads, that's all your equipment and your efficiency. And if you get into industry, you have steam and compressed air as other systems. And so whether you're talking about a pharmaceutical company or a school, you still have those systems. And so as architects, engineers, energy managers, we're looking at things from a systems-based approach and can identify conservation measures through that whole assessment and efficiency process. And then once those are optimized, you add in renewables, add in other sustainability practices like F-gas management, the water optimization, that waste optimization, continual monitoring, which is getting a lot more effective and efficient with artificial intelligence, and it's identifying opportunities and ways of working that we haven't seen before. And then, of course, if we're doing decarb, I think I have, yeah, there it is. If we're doing decarb, you can also then offset the remaining emissions. This was a project that I worked on. So when we go through these assessments, you can see that there can be significant cost savings, especially in these larger sites with industrial applications or working with a pharmaceutical company. Labs could be having 40 air changes per hour when a space only needs 8 air changes per hour. You could compromise down to 12. That's still a huge reduction. And those optimization opportunities end up benefiting the bottom line significantly. And so when we're starting to talk about this, it just makes a lot of sense. And you can see here's energy conservation measures that were identified. There was about, between a DOE treasure hunt and an ASHRAE Level 2 audit, they came up with different opportunities. totaling 164 different projects. And then those projects resulted in this identified savings. Something that I think a lot of people might be familiar with in here, this is a fun chart of midnight to midnight, and this is a calendar week. So this is an office space, and this is the hours of operation that are in red. So this is when it was cooling. And then we did unoccupied setbacks. So you can see from this unoccupied setback, it ended up being a 20% energy reduction in this building. And you can see that the building was turning on around, late in the day when the building was getting latently warmed by the sun, and then just cooling down from like 6 p.m. or 10 a.m. to about 6 p.m. And then over here, same thing from about 2 p.m. to 6 p.m. on the weekend. So just those unoccupied setbacks end up with significant amount of savings. I just wanted to show a visual around that. This is a little bit of passive design. This over here is a cupola. You may have seen these on old buildings. I think it's really cool what we did prior to the World Wars. There was just a lot of intelligence in design, a lot of passive design strategy. So heat rises. So that cupola ended up getting heated. The walls in these old school buildings, this is in Washington, D.C., Powell Elementary School, had foot gaps between the classrooms. So you'd open the windows, which were under oak trees, and it created the stack effect, which created a natural breeze, and moving air has a cooling effect. So then it created this natural cooling effect, and then the air would go up and and then we replicated that in this modern addition here with a solar chimney. So utilizing that same principle in addition to a shade wall on that southern facade. And just understanding this, the way that this building moves in relationship to the sun, where the natural breezes come in, how it's oriented with trees that are existing on site, or the local environment itself, like the urban planning. This highlights like the lighting design, how that air flows through the classroom, how light bounces in the space, how there's operational windows. So this is a snapshot of a bunch of passive design strategies that can apply to a building. And this isn't just, this has super tangible benefits. Here's a different kind of shade wall. This was, I thought, really awesome because it reduced the size of the HVAC system by 28 tons in this 4-story school classroom, and this is facing south. And so not only did that have a 10-year ROI, but it reduced the glare in the classroom, so it improved the learning environment for the students. And since it reduced that heat loading, it also created a more comfortable space, so you don't have that temperature differentiation between the wall and the inside, or the exterior and the interior of the classroom space. But then you can start to quantify tangible benefits from doing envelope improvements. And part of it is shade walls. That's one example of a shade wall. The other ones are the overhangs. Those overhangs could also be done at another building. I've seen this done a few times where they use the overhangs and they put solar panels on them so that you're generating electricity while you're shading. So it's a 2-for-1 strategy. And improving the building envelope. If you're doing this for a residential home, you put an extra $6,000 into your building envelope. And prescriptively, you would put a 3-ton HVAC system on your average townhome. Well, if you enhance that building envelope, you can decrease that down to a 1-ton system. So you transfer that line item cost from the HVAC to the envelope because you've now made it more efficient. You don't have that pressure of heating and cooling the outside as much. And it's similar on this. This was a 300,000 square foot office space that was built in the 1980s. This over here was the annual utility bill of about, I'm just going to use round numbers, $300,000 a year with energy use intensity. So that's how, like, so to normalize energy in a building, that's the kBTU per square foot. So that way we can say, like, hey, this building is similar to this building. This is the building's EUI. So that building had an EUI of 92. And then to a code built building, we were able to reduce that down to an EUI of 50 and a utility expense of 163,000. But then enhancing the building envelope, so putting on added insulation, having thermally broken windows, and putting in a shade wall, we were able to reduce the EUI down to 23, and then the utility expense down to 56. Now you could do more additional, like, super improvement of the HVAC system, but you're talking about 3 million more in cost to save 7K in expenses, which gives you a 429-year payback. I would not advise that. That would not be advisable. What I think is really cool about this is an example in where if we think through that passive design strategy, enhancing the building envelope, and thinking through the overall strategy with an enhanced envelope compared to typical code-built buildings. And this up top here is the cost of PV for what it would take with that new energy intensity in all cases to achieve net zero. So you can now build a net zero energy building with that building envelope cheaper than you could with the code built building and the panels. And then you're saving all that site space in addition. So there's now awesome cases that net zero can make a lot more sense, and we can reduce our overall energy use intensity, which is super key considering the electrification of everything. If we can use less energy and continue that electrification journey, we're going to set ourselves up for more success. Dunbar High School, there is a delay. Dunbar High School is the highest LEED rated newly built high school in the world. It was built 12 years ago, and nobody's stolen that title away from it, which I think is super cool. This is a project I worked on. It was also the first power purchase agreement for Washington, D.C. The east-west orientation of this building reduces its energy consumption by 10%, and it has shading on that southern facade, which reduced its energy consumption by another 5%. It put geothermal under the football field, which further reduced its energy consumption. And it's absorbing all the rainwater from a storm event and putting it in 2 school bus size cisterns, and then using that to flush the rainwater, which Washington, D.C. created this situation where they have a fee if you don't absorb the rainwater from a normal 1.2 inch rain event. So now we had a 10-year ROI for this building for capturing and reusing that water on site. Again, with this one, we had a target EUI of 20. We achieved 23. I thought that was pretty awesome. But even with this being the highest LEED rated newly built high school in the world, there was a major opportunity to improve its efficiency. So we ended up reducing its energy consumption. I let the building engineers do what they had to do for the first year. Like, figure out the building, figure out how it works. It was commissioned. When you commission something and you commission a schedule, they're just like, hey, does it have the ability to be scheduled? Yes, check the box. That's great. But is that schedule optimized? The answer to that question is often no. So in this case, where this arrow was, most buildings are operating 72 degrees year round. In this case, we had setbacks in. So again, this is like 1 calendar year and then midnight to midnight across. So as you can see from here, the outside temperature, it was 8 degrees in the city for a couple days. So we let the building run all night because it never would have been able to catch up from that thermal drop. But that still saved all this other energy. And as the summertime hit, I had a conversation with the building engineers because I was like, hey, look, you're not in this building until 10 p.m. or 11 p.m. This is the last hour. And so, and we're not starting that programming until 9 in the morning. And so then we sat down and had the administrative staff talk with the facility staff. And then you can actually see how we have all these cuts in for every weekend. And how especially down here, you can see how the schedule was able to ramp down significantly, saving in a high, the highly rated building. Just because it's in the energy and environmental design doesn't mean it's implemented. And so going through and following up on that implementation is a huge win. And it's not just government that's doing this. Amgen has a facility out in Ohio that's working towards zero carbon ready. It's 300,000 square foot industrial space with 400 staff. And this building is carbon neutral. And you can build these systems for around the same price point as you can a conventional building. And a big part of that is thinking through which HVAC equipment you want to put in addition to that building envelope. So with adiabatic fluid coolers and air source heat pumps, solar thermal, especially solar and thermal storage, we can get rid of the cooling towers that are on the site. And this does a couple things. It gets rid of a significant portion of a site's water consumption, which is a huge win. And then it allows us to optimize those HVAC systems. Another company has a product coming out that is a heat pump that produces steam. And like up here, you can see Atmosphero has designed this building or this boiler, where here's the cost of natural gas in the US versus EU, which is more. But if you put in an electrode boiler, which is electric resistance, especially at a large industrial site, you're looking at having, a draw of 10 megawatts. You're looking at increasing that draw with electrode boilers up to 22 megawatts if you switch out your boilers for electrode boilers. And if you're looking at what your transformers are bringing into your site, well, you might have a maximum capacity of 11 megawatts per feed. You have 2 feeds, that's 22 megawatts. You don't want to max out your site because then you have no room for growth in that industry. And so at this stage, you would not want to electrify that site because either A, you have to pay $50 million for a utility upgrade with a transformer upgrade. It's a significant capital expense. But this type of technology is coming into the market where now your energy increase is only going to go up by 5 megawatts. So then you still have that 7 megawatt buffer in that scenario so that you can still grow as a site. You could electrify. You're not doubling your electric costs at the same time. And so there's a benefit for having a strategic plan, which I'll get into the middle section of this presentation, around how to phase in emerging technology. And this is that renewable hierarchy that I was talking about. When you can, 100% put on-site renewables. We're losing electricity when we transmit it through the grid. There's resistance, there's friction, so we lose energy from wherever it's coming from. So the more that we can generate locally, the more effective we're going to get. I mean, we all have cell phones, we all have computers. We're having an increased amount of electric vehicles. All of that is direct current. We have alternating current, but we're creating this solar panel, this energy from in our solar panels, and then converting it to AC, and then, you know, all of us have these converters to go back to DC to charge the batteries. But if we just have dedicated direct current in our buildings and start thinking through how we could have direct current televisions, direct current appliances in the home, direct current cell phones and computers, we'd be able to reduce the amount of electrical loss within our systems, and then you'd be able to have dedicated power at your site without that loss in conversion between phases. So that's like a huge emerging opportunity. But then you can also take your existing power, whatever your grid mix is, because there's nuclear, there's coal, there's natural gas, there's wind, there's solar, and buy RECs to offset the difference, renewable energy certificates. But that's a cost plus. In some grids, if you switch to a virtual power purchase agreement, so this building could buy its energy directly from a wind farm, and if it's virtual, you know that energy is going in there and you're metering it out here. And so then, and you're claiming the environmental attributes, you're not sell it through the REC system. In that way, in some grids, it depends where you are in the country, that can be cheaper than brown power. And so there's some ways, depending on where you are in the country, that a lot of entering into a virtual power purchase agreement is also a cost savings mechanism, not just a greening of the grid mechanism. That and the REC market it's a market rate, just like the stock market, it changes. The price had gone from 50 cents to $3. And so you're at risk as a business if you're purchasing RECs and using that as a decarbonization or a net zero strategy. This is a super interesting, there's fossil natural gas. We all know that emits carbon to the atmosphere. Renewable natural gas from landfill gas is half the carbon intensity. It still has a carbon footprint. Anaerobic digestion of organic waste, so from industrial food waste or animal waste, actually has a negative carbon impact because it's removing the methane that's going to the atmosphere. Methane is up, anthropogenic methane is up 170% since the Industrial Revolution. And being able to monitor, capture that amount of material, and then displace fossil natural gas is a long-term strategy for mitigating methane to atmosphere and mitigating climate change, but also an immediate strategy for utilizing your existing equipment and displacing fossil natural gas. It's a hot take. Not everybody agrees with that, but this is that step 4 where I was talking about best practices, fluorinated. It just takes a second. Fluorinated gases. So every refrigerator, every air conditioning unit, every chiller, all has refrigerants, and those refrigerants have a global warming potential. The ones that we've used historically are like 1,500, and sometimes almost up to 4,000. Newer ones are between 400 and 600, especially ones that are available in Europe. Natural refrigerants can come with their own challenges like ammonia or carbon dioxide. And we're still figuring out how to have the efficiency with less globally impactful refrigerants. But we're moving in that direction because, you know, this facility is going to have fluorinated gases in it. Yeah, if there's leaks, fix the leak. Yes, you're not leaking the entire system. But the reality also is if a tornado takes out this entire facility, all of those fluorinated gases are going to atmosphere. And so you have a total release to atmosphere and you've completely impacted the environment. And so when we're looking at these large storm events that are happening globally, we're also looking at the equipment and the refrigerants that are in those buildings being completely released to atmosphere. And so swapping those out for different gases and having a replacement and a management plan when there is a disaster and you have a total loss of product which is not typical in normal operations, there is a way to reduce that overall impact. Emergency generators, still the best way to have emergency generators is diesel. And so that ends up being a constant fuel source or fossil source of emissions. Batteries don't last as long. Battery technology is coming along. There's different strategies, but e-gen alternatives is definitely a huge potential area in the marketplace. One thing that I found is, I think the waste industry must still be controlled by the mob because they're pulling air and charging you for it. And if you go outside and you look at your dumpsters on the day that they're pulled, they might be half empty, which means you could half the amount of times that you're getting that dumpster pulled, which means you're going to half your expense with your waste management. There's significant opportunity around waste. People don't look at it because they're just like, whatever, it's a sunk cost, but it's actually a huge opportunity. The same thing with water. We get a lot of rain here, but how many people I've seen somebody's sprinkler on and then it's raining outside? There's significant opportunities in that space. And then compensation. I think this is really a huge opportunity. We can capture the carbon dioxide off of our boilers, especially at industrial plants. Coca-Cola in Puerto Rico, for example, captures the CO2 off of their smokestacks. They clean it up. You can clean up that carbon dioxide, make it food grade, and put it into the sodas. So they're using their own emissions into their product, which I think is awesome. You can also plant trees. I know that that's a short-term strategy. I'm going to talk more about trees in my take on short-term nature-based solutions in another segment. But about one tree absorbs 150 kilograms of CO2, so about 7 trees for a ton of carbon dioxide emitted. How many people know how many gallons of gasoline emit a ton of carbon dioxide? I think this is fun because like understanding what a ton of carbon dioxide in the atmosphere is something that we don't have a comparison for, right? 104 gallons of gasoline combusted is a ton of CO2 in the atmosphere. So it gives you a sense, like now you know when you're driving your car and you put in 18 gallons, once you get to 104, you've emitted a ton of carbon dioxide into the atmosphere by just driving around the car. So now you know how much a tree would absorb. So it takes 7 trees to absorb that. So it gives you an idea of like what's needed in the environment to offset some of your own emissions, and then you can get a global sense of how that scales. But through that whole strategy that I just walked you through, there was only about 2% residual carbon emissions, about 1,500 tons from the F gases, those ozone depleting substances, solvents, or employee travel that we're going to have to always, with whatever we do, pull carbon back out of the atmosphere. Getting to zero carbon is like getting to zero waste. You can get a zero waste certification if you get greater than 90% waste diversion. I think it's smart that the Science Based Targets Initiative said, hey, you can offset up to 10% from carbon sequestered sources, because it's near impossible with the systems that we currently have in place and what we're looking at up to 2050, so for the foreseeable next 25 years, that we're going to get to zero, but we can get to 98%, and we have the technology to pull that other 2% out. And so building up those systems is key to having that total decarbonization strategy and that net zero strategy for buildings. I'm going to stop there, take any questions as it relates to buildings. Yeah. I think we're going to get to a mic. Hold up.
Is that 104 gallons of gasoline used, burned, whatever, produces 1 ton of CO2? I just want to make sure I had that.
Yes.
Okay.
when you combust it in a car,
when you
like
combust
you
it.
burn it. Yeah.
Question about Dunbar. So a couple of questions. I assume that the taking care of 1.2 inches of rain is a design measurement, as in it's a one-time thing. It's not, DC is not going around measuring how you're doing it, right? You're saying it from the design aspect.
Absolutely. So the average rain event is 1.2 inches. And so they're saying you have to design your site to absorb the rain from that. So when the rain falls, so capturing the water that's falling on the roof, and then also from any of the sidewalks or the street, not just having, so what, one of the
The
things
proof
that
is in the design, though,
it
right?
is in the design. Yep.
And then the other question I had about that, about the scheduling, since I work for Seattle Public Schools, uh, do you know if DC has any policy about building schedules? Because, we have a policy about when the building has to be up to temperature, and we have our deadband that we are aiming for. And, it's our policy, and it varies by the building, of course, whether it's newer or older, about when we need to start up our systems. So I was just curious if you knew DC's policy.
Yeah, I ended up writing it with them. Um, uh, 100%. If the building has to be ready at 6 a.m., it has to be ready, and you set and you can program the building to be ready at those times. And especially with AI and understanding the weather that's coming in, the building might have to turn on 30 minutes before the students get in, or staff is getting in more so than the students. But also understanding, because weather is being inputted into those models. So during that modernization, we were able to upgrade a lot of those systems. Um, if you have the ability to look at those weather forecasts, right? Like, so if we're having a 15-degree day here in Seattle, which is super rare, those systems are going to need to understand that 24 hours in advance so they can be prepared probably to stay on all night so that the system's ready in the morning for students. Otherwise, if you're trying to turn on at 2 a.m. because that's its earliest start, you might never catch up because the buildings here aren't designed to be in weather that cold. So it's a matter of having that programming in place, but then having an optimized start and an optimized stop so that it adjusts, so it starts only when it needs to be ready. It'll sometimes start way earlier and sometimes start way later, but optimized start stops helps with that. And then we also developed a relationship between the facilities team and school administration, because the schools would be off on the weekends. But if there was an event on a Saturday, which happens, the school administrative staff would communicate that in advance, and then you'd do an override in the system so the school building would be ready. The school is there to be utilized by everybody at all times, but we're going to operate it this way. If you want to go outside of those hours, just let us know 48 hours in advance. So it was developing that policy, procedure, and communication that led to success.
Yeah. What is renewable natural gas?
Fossil natural gas is mostly methane. Renewable natural gas is also methane. It's just from what is described as renewable natural gas is the methane that's captured off of a landfill, even though that still has like a fossil impact because we're capturing methane that would otherwise be going to atmosphere, or it's being anaerobically digested. So like little microorganisms are capturing that off of food and manure, or so animal waste, and then capturing that in a closed system and then putting that into the pipeline, but it's capturing that methane. So it's just methane from sources that are renewable as opposed to fossilized.
Okay. And the other thing I wanted to comment on is you started your presentation talking about passive strategies for cooling. And I'm an architect, and it's always bothered me in the 80s when we started building these glass office towers. And so just wondering, I'm just thinking locally whether cities and jurisdictions are incentivizing passive strategies, or whether SEL incentivizes it, right? Which is not buy the latest and greatest heat pump, but rather put some shades on the south windows and put a cupola up. And, you know, because architects ultimately have seemingly forgot about passive strategies in a lot of cases, or they don't think it pays for itself, or it's not incentivized like buying an expensive heat pump. So
Absolutely. And LEED doesn't give you points for passive design, right? So even some of the systems that are structured to give you credentials for those elements of design don't necessarily have all those. They're not giving you extra points for passive design. Capital One in Pittsburgh, the Capital One office tower in Pittsburgh, can naturally ventilate. And so there are examples where this does work. It needs to be scaled, especially in a place like Seattle. The weather here is optimal in the summer for what, probably 6 months at least. It's low humidity. It's pretty comfortable. If you just had airflow, I think most people would enjoy just getting the natural air. But there are instances like that is done and it can be replicated. Anybody online?
Turn this mic on so people online can hear it. Megan is wondering, I thought this was a good question. Back to the trees removing carbon dioxide. So the 7 trees remove 1 ton of carbon dioxide per year?
Yeah, that's
or over
annual.
their lifetime? Okay, per
Yeah,
year.
that would be annualized.
Okay, okay.
And they also have to get mature. They have to be mature. So like there's a nonprofit entity called One Tree Planted that I've worked with. So like a corporation would work with them to plant trees. They're going to ensure that that tree also survives, because if the tree dies, well, it's not absorbing carbon if it's dead.
Right.
But like to get to a point where it's absorbing that 150 kilograms per year per tree, it takes about 5 years. And then as a tree gets older, it slows down in its uptake. But like, it's a strategy for now.
Right, okay. And then I had a question. Was it the high school, was it in DC that did geothermal under its football field?
Yeah.
I don't think of DC as a geothermal hotbed. So how much did that system really supply?
18% energy reduction for that.
Wow.
For that campus.
Wow.
Because you get to 3 feet down, and I think the annualized temperature 3 feet down is like 64 degrees.
Okay.
It was basically ground source.
Yeah, it was ground source.
Not geothermal.
Yeah, not electric geothermal, but yeah.
Yeah. Thank you.
Awesome. Oh, one more.
You just described some really amazing design components and complex designs, and there has to be so much training that's needed for the people that are actually operating and maintaining the buildings once these items are in place. So can you talk a little bit about your experience training folks and what that looks like up front versus over the course of the building's life?
Yeah, absolutely. Building engineers and facilities teams seem to be some of the most knowledgeable people that I've ever met. They understand what's happening in a building. At Dunbar, the building engineer said, well, we can't turn the whole building off, because if I did that, we'd have this sink of air in the space. So they had to stage the building off and stage the building on, because of the way that the building was designed and how air flows within the building. And so it's a very open dialogue. It's having a conversation of saying, hey, we want to optimize how we're operating this space so that we end up with this energy efficiency. And I know that you have to, and you are graded on, and you get really nasty phone calls if it is not good when you want it to be good. And so we need to develop a conversation. And that's where I was like, we sat down, the facilities team with the administration, and said, hey, this is a partnership. Like, we want to give you what you need when you need it, but we also need to have an understanding of like, this is typical operations, and like things are going to drift to maybe potentially uncomfortable levels when nobody's in the space. But the computer systems are pretty intuitive, so it doesn't take a lot of training. They're building management systems. Uh, a lot of people do know how to operate those systems, and sitting down with control engineers and especially engineering students that are coming out of school are super used to computer systems now and running and operating. And you also will get people coming from Schneider Electric or Siemens and coming to work for um, a district, and then they know how to change some of the code or programming, and that super helps. So there's a flow of information and partnership that's involved, but setting the stage and having open communication is the only way that works. Otherwise, there's a lot of angry phone calls and finger pointing.
All right. Colin is wondering, well, he's describing in Phoenix, Arizona, there's an energy microdistrict downtown where they run systems overnight to create ice, which provides additional cooling capacity during the day. It allows the equipment to run more efficiently at night and reduce peak energy demand. Have you seen anything similar in other places or in other buildings?
Absolutely, and there's a huge amount, there's a bunch of incentives that are happening in that space. It also happens in Houston, Texas, where they use the buildings basically as like thermal batteries. They'll like super cool them at night. They'll also do this in the Anaheim Conference Center, does the same thing. It super cools it at night, so it's a little cold when you get there first thing in the morning. And then they don't have to work their systems as hard during the day. And it does get a little bit warmer, but not super warm by the end of the day. What it does is it displaces the time that you're using energy, so your off-peak energy, to better cool the building. You reduce the thermal load of the building at times when energy is cheaper. And in that demand response, utilities, districts, buildings can also get an incentive from utilities. So that is a strategy, and it's also growing as the climate is warming in bigger buildings. I'm going to jump into corporations. So I just figured I'd break this up so you all can have like some conversations along the way. And if you need to go to the bathroom, just raise your hand and ask permission. That'll be fun. Exactly. So this is very similar in let's first assess, let's understand. Let's understand where our carbon is coming from within an organization. This is, what is my business travel? How many sites do I have? Where are they? What is the grid? And then setting targets. Now this is a little bit different than the buildings. So this is like the Science-Based Targets Initiative, the Sustainable Development Goals, the Climate Disclosure Project, and then of course it's with that renewables. And now we get to engage suppliers. I've heard that if everybody at scope 1 and 2, then your scope 3 is solved. But that's not necessarily true. If you are Tesla and you are bringing in batteries, and that material that's coming in the batteries, that's not somebody else's scope 1 and scope 2. That is your scope 3, and mitigating the carbon emissions from that material and the mining process is not something that's going to be completely mitigated in their scope 1 and scope 2. And so understanding how to mitigate scope 3 is super big. Does anybody know what I'm talking about with scope 1, 2, 3? I'll get to it in a minute. And then mitigating that remaining emissions. So like on this slide, we have like the Climate Disclosure Project, Science-Based Targets. They've all been around since the early 2000s. Things really changed in 2015. Something happened that's never happened before. The Paris Accord, every nation on the planet signed it. And they said climate change is real and we need to do something about it. And that really sent a market signal that corporations need to step up and have a way of navigating this, because the market is saying if climate change is real and we need to do something about it, well, we're setting energy, water, waste reduction targets. So you saw corporations set these 10-year targets 9 years ago. So they're starting to be realized. And then at the same time, there was that like zero carbon by 2050. I look at this a little bit differently. I look at it as 50 shades of green. So like we're light green in 2015 and we're going to be super dark green in 2050. But it's going to be steps along the way. Just like I was like, right now we all have boilers in our building. Maybe they have another 10 years or 15 years on their life. How many people have replaced a refrigerator in their house only to have a more efficient model come out the next year? Use something reasonably till the end of its life. There's embodied carbon with that until it's like broken down and not going to be used anymore, because we just end up and then slowly transition. And then in that way, you move through these like shades of green, right? I almost want to create my own rating system, be like, you're at shade 20 right now, you're at shade 35. But these direct and indirect emissions. So direct emissions is scope 1, your company facilities, your company vehicles. Your scope 2 is the indirect emissions. So it's the electric, it's the steam, it's the heating. And then scope 3 is really it's the majority. It's 94 to 98% of almost every corporation's emissions. And it's your purchased goods, it's your business travel, commuting from your employees, transportation, distribution. So it's downstream things that go into your company and upstream things that go into your company and downstream things that go out. Like it's like Coca-Cola, I guess I'm picking on them today. Their plastic bottle at the end of their life is a downstream product that should be taken care of in their scope 3 emissions. So if they developed a different bottle, they might be able to mitigate that form of scope 3 emissions and also plastic waste. And this is where not only does scope 3 sustainability intersect with net zero and decarbonization, but this was developed as a way of ensuring sustainability across all of these different regions. So different corporations can work towards, if you're Nestle and you're dealing with food, you might align with zero hunger for everybody on the planet. A lot of organizations are aligning with climate action. If you are tuna under the sea, life below water would be really important for you. And so it's a matter of aligning with these different sustainable development goals, which have different responsibilities and different people working on different facets of them. But it's a way that corporations can come together, rally, and create global impact. This is, our current state of, fossil natural gas is a big, a bigger part. It's over 50%. We'll say in this case, like 60% of the fossil emissions, and then your electric is your other emissions, and then you have your other GHG emissions from those refrigerants and other like travel and other things in your company. And so then, an immediate strategy is to purchase renewable natural gas, do a power purchase agreement for green electricity from power or solar, and then you can do carbon capture and sequestration. It's a big word. Why does it do that? I think of this as like a 1,000,000-piece puzzle. Now I've simplified it here to 4 pieces because 1,000,000 pieces on a slide would be hard to show. But it's a matter of like, hey, we're in 2025. How do we offset our fossil gas? Well, it's, on If you're a company, you're going to have 20 sites across the entire United States. The Midwest, your utility is like, hey, I want to install a utility scale solar field. I need a major off-taker in order to warrant this project. I'm going to pay for electrification. I'm going to pay for the transformer and an upgraded service to your facility. You have to take care of the equipment inside your facility, but I'm going to pay for everything to straight to your meter because I need a large off-taker. And it's like, oh, awesome. I'm going to have power from you. You get to build this project. We now have additional renewables going into the grid because of the project we're working on. This is amazing. Another project, another operational site, the utility asked them to turn on all of their emergency generators on a hot summer day because the grid can't handle the load. And so often there is the utilities coming to individual companies and saying, hey, I need you to not draw electricity. I need you to go into an island mode right now. And that is a reason why we should not electrify that site and do renewable natural gas. We can, especially with that anaerobic digestion that I was talking about, it's carbon negative. We're displacing fossil carbon. We're utilizing existing equipment. We're working with our utility. We're working in partnership. And then we can have a conversation. This is an untenable future situation. We need to figure out how to move the needle. And so then we end up developing a strategy where the utility, private enterprise, and government has the ability to work together to affect change and look at that new lower carbon technology over the next 20 years, right? Like, this is a very pragmatic approach. Do we need to decarbonize right now in order to mitigate the worst effects of what we're experiencing? Absolutely. At the same time, like in that situation, the best way to do that is to switch to renewable natural gas from anaerobic digestion and purchasing your electricity from a wind farm and reducing your F gases. And that's where this comes into play, where this is like a whole strategy of you're doing your electric, you're doing your renewable natural gas, you're thinking through your F gases, your emergency generators, your carbon capture, you're hedging those utility costs because of the savings that I was talking about before. Remember how we were talking about all those energy savings projects? And a lot of strategic planning and then getting in procurement language. That's been the biggest thing is, hey, we're going to the market. We want Model A boiler. Well, you know, they're just going to give you Model A boiler. But if you put in that RFP package in your proposal that like, hey, I want this or something more efficient, and upgrading that language to always be asking the market for, hey, is this your most efficient thing? Or do you have something coming into the market in the next year that's going to be more efficient? Because they might have something in the next 6 months, but it's not right now. It might make sense to delay 6 months if that's what you want. And so making sure that you ask that question has been huge in really navigating how to move forward. And this is how you can decarbonize over 10 years from having the total tons of emissions in a corporation, and then you decrease that with those renewable energy credits that also can be a virtual power purchase agreement. Either way, the Science-Based Targets Initiative looks at this as a decarbonizing mechanism. And then you can actually see here how 2023 is less than 2022 in carbon emissions because we've started to implement those energy conservation measures, reducing total site energy consumption on that graph earlier in the presentation. I know it seems like last year, by 23%. And then with that renewable natural gas, you're now down to 98%. And then with that carbon capture, either that flue gas or at this time planting trees to absorb that difference because those trees wouldn't be planted otherwise. You're pulling out that carbon until you can develop a better strategy in the next couple of years. But it's a right now scenario where this corporation, through these efforts, can show quantifiable, tangible, not only reduction of total resource use, but also a mitigation to zero carbon. And yeah, does something else have to happen before 2050? Yes, this has to continually improve. I would call this maybe 35, 40 on the decarbonization scale to 50 shades of green. More has to be done, but it allows us to decarbonize right now. And I think the biggest thing for corporations is to understand that, yes, you can see that renewable natural gas is significantly more expensive than fossil natural gas. And your electric rate might go up if you're averaging out your sites across the country. And water continues to cost more as water becomes a more scarce resources and more intermittent. But you can see here how much we reduced our electric. You can also see here, because of a steam study and maximizing the use of the boilers, at one site, we went from having 5 boilers, 2 had pneumatic controls, 3 had digital controls. We were able to get rid of the 2 pneumatic older boilers. And with the steam study, we found that instead of using all 3 boilers all winter long and 2 boilers all summer long, we only needed 1 boiler at 60% to 70%, 7 months of the year, and the second boiler even in the coldest months of the year. And then so we had N+1 with 3 boilers when we thought we were going to have to add 1. And so that significant reduction in energy, which was almost half of gas consumption, ended up with, even though a significant cost increase, not as much of a cost increase as it could have been. And still identifying ways to reduce water, because that's a financial savings. Waste went up at this site because they continued to grow in operation. So they were growing by 30% in output from 21 to 22. So you can still have absolute energy, water reductions and still grow your business. Those two things are not different. They're not separated. And then, of course, taking into consideration the cost for sequestration. So now you can have a decarbonized site for $500,000 more. Yeah, that's a slight cost increase, but that's not above inflation. So I think this is really important to note, that you can predict that, and then those power purchase agreements that you put in place offer a known predictable rate of cost, which helps an organization mitigate risk, as opposed to not knowing what your electric rate is going to be in 10 years. We don't know, especially with increased pressure on electrification and increased demand. Your rates could spike. So this carbon neutral scenario could be more cost effective. So it allows you to hedge against those future cost increases. So road mapping for facility systems, like earlier in the conversation I was talking about, it's like a systems-based approach. And this is like a strategy. I'll just leave this up so you guys can look at it as working through it. There's renewable natural gas. Hydrogen is it's been a really big conversation for years. It continues to be a big conversation. There's a lot of money that's going into it. I think hydrogen has a role to play. I think that it's going to have a bigger role to play at an industrial site where it can be used right next to where it's being manufactured. And so, right, like this is a 1,000,000-piece puzzle. I think you'll be able to use hydrogen in those situations. I don't know how. It's such a small molecule, there's no way you could put it in existing natural gas pipeline. It would leak all over the place and we'd have explosions everywhere. That would be lots of fun. Be like 4th of July every day. Electrification is also a part of it, but we have these different tools in our basket. Like I was saying, like optimizing with the boilers and the steam system, sequencing your boilers to turn on and turn off, looking at the pressure of those boilers, what the demand is versus what you're producing. Sometimes we're just giving the system more than it needs. I don't know, variable airflow, a lot of office spaces, having all of those VAV boxes talk to the building management system, and they can open and close when in use. There's a lot of technology, smart building technology. Some of it's really cool. It's like, hey, there are 20 people in this conference room. We're going to increase the airflow. But if nobody's in this space, but only this morning in this room, well, the airflow to this room could be significantly decreased the other days, right? If you understand what the carbon dioxide levels are, but either having occupancy sensors or other mechanisms to know what the airflow needs to be. There's so many different opportunities in building systems. It just needs to be justified with cost and see what makes the most sense for you. These are rooftop units. I've talked about freezers and green refrigerants. I'm just bringing ozone depleting substances up because there's other elements to it. And then talked a little bit about building envelope, lighting, HVAC. If anybody wants me to go in more detail, we can go into that when Q&A. Supplier engagement is huge on all of this because that's that scope 3, and getting like a big part of our total emissions. A lot of it's coming from agriculture and food, and understanding how to manage that. That's where I also think that anaerobic digestion has a role to play. Something that's really emerging in that space is also biochar. Biochar, it's a combustion of organic material, and it turns it basically into coal. For like, if you want to visualize it, it's like a solid carbon element that you can apply to soils, but it also breaks down chemicals. So if we implemented this at waste treatment plants, it starts to create a holistic strategy that breaks down, unmetabolized medicines, PFAS that are going out through our systems. And so there's different strategies that we can do to reduce these overall emissions and consequently other elements of impact on the environment. And then in here, you can see just engaging your supply chain is big because historically we've had this black, right? We've had this flow through of materials, suppliers, manufacturers, distributors, boom, dispose of it. It's just a flow through. And so from the user and the consumer, figuring out how to collect and maintain and repurpose, reuse, remanufacture, recycle. We know that recycling is not what we were taught that it was. We can re-envision this, and I'll get a lot more into this in the districts thing. But there is a massive opportunity here, and especially corporations engaging with their suppliers have an opportunity. The back end of this is these are some of the major carbon credit companies out there. Carbon offsetting, I hate the word offsetting, but it's kind of how people refer to it. You have these projects that are financed to reduce emissions from these heavy emitters so that they can be compliant with these international targets. And the intent of this, best laid plans, isn't that like Exxon is planting a whole grove of trees to offset their carbon emissions for the pulling of fossil fuels out of the ground to continue to pull fossil fuels out of the ground, but instead that a biotech company in Seattle is doing what it can to reduce its energy consumption but then it's only gotten so far, so it can feed corporate dollars into different carbon credits. And here's like a whole slew of different carbon credits that are possible. The Science Based Targets Initiative has said, and this is where I think we should be in 2050, this is a hot take, is that have that 10% permanent carbon sequestration in 2050, 100%. Right now, the only two mechanisms for that is that biochar that I discussed and direct air capture. Lots of money, lots of energy to do direct air capture of carbon and put it into the ground. We are looking at, I mean, you even look at around here, the Puget Sound ecosystem could be rehabilitated more, like the giant sea star that used to live out there. Where is that guy? The ecosystems have been impacted. And these these nature-based solutions offer a pathway for improving biodiversity and improving our ecosystems. There's an initiative out there called 30 by 30. Has anybody heard of that initiative? Like 2 people. That's cool. It's but no, it's not very well advertised because I think it's also difficult to accomplish unless we allow corporations to use this pathway to accomplish it. It's a matter of like setting aside 30% of the terrestrial land ecosystems and aquatic ecosystems to exist and to be. And if we do that, then the idea is that we can survive the changing climate because the ecosystems are intact enough to be resilient to stand the changing climate. Right now, they're super fragmented. And so it's also akin to saying like, hey, this company just came through, bulldozed this whole entire tract of land, and then they're like, hey, you're going to give me credits to replant this, to reseed it. Okay, cool, I'm going to go ahead and reseed it. It's like, great, now we're restarting. That's awesome. But now we're in a situation where they bulldoze that land and they're like, hey, I'll reseed this, but I want some points for that. They're like, we can't give you points for that because that's like an incentive for you to bulldoze the land. And it's like, okay, well, fine, I'm not reseeding it. So now the land doesn't go reseeded and it doesn't have a chance to recover. And with the way that things are changing right now, allowing for nature-based solutions allows for that funding to go back. These things have been bulldozed in that analogy, and it allows for those dollars to go back and rebuild those ecosystems. And then we could accomplish that 30 by 30 initiative and prepare ourselves for a warming climate. So I think it's, there is a mechanism out there that's already in place, that's working. Here's a whole bunch of different ways that can be accomplished. And we have like 5 years to get there, and we're not there yet. But I'll take a pause here to answer some questions about decarbonization, net zero for corporations.
No one's got one. I got one
Cool.
from the chat. Sound like my kids. Selena was wondering, there was a slide that said if equipment needs to be replaced, needs replacement before 2030, replaced before 2025. Was that on one of your slides?
It was.
Okay, so she was wondering, she thought maybe she missed it, but what's the reason to replace it sooner?
So it's like, it's a really good question. The idea for that was if we are putting in renewable natural gas by 2025, what equipment is so inefficient right now that it warrants replacement that's going to benefit us from that 23% efficiency in that corporate scenario that I used? So if it's going to give us this massive energy savings right now, great. If the equipment is good, kind of, and it doesn't need to be replaced until maybe after 2028 or 2030, well then wait, because that heat pump to steam boiler is going to be emerging technology. So if it's really inefficient, replace it right now. But if it's good and it's not bad, if it's a refrigerator that's working, don't replace it yet, because you're going to get a new efficient one in the future. But if it's already starting to go and it's older, replace it now. So it's that kind of a strategy and approach and thought process.
It's not so much a question as a beef, but I wanted to flip the, you're talking about corporations as in what can they do, but my issue about large corporations and their greenwashing is they put the onus on the consumers, and because that's profit driven. And it's like, you can do better recycling and you can do better by reducing your waste, except what you're saying about recycling is like, yeah, now China's not taking all of our recycling. What are we going to do with it? It's just because it says on packaging that it's recyclable doesn't mean that there's a market for it, or that it should even be packaged in that thing in the first place. So, I would like to see a lot more corporate responsibility from the top end down, but really it is profit driven about how those decisions are made, and that is why they put the onus on the users rather than. So I know I'm flipping you're addressing what corporations can do to reduce and change their models, but I would like to also say that I feel like they have a responsibility.
100%. I completely agree. And there is work in that in those supplier conversations. Two examples. One example is having worked for pharmaceutical companies, they will send out like the new the proteins come in pen, like those injectable pens that you've probably seen. You've probably all heard of Humira. It was like a big push on the commercials. They've gone out in styrofoam boxes with these freezer packets and air bubbles and all these things, one at a time to the consumer. And then Thermo Fisher now has a cardboard box that comes out with insulation that's made out of like recycled blue jeans, which can be composted. And so the box can be composted or put into cardboard recycling. The inside could be composted. The freezer packets are like a biodegradable gel. And so there is a thought process around reducing the amount of packaging or what packaging is going out. I think also the insurance companies could send a 90-day supply as opposed to a 1-month supply, right? So as opposed to sending something out 12 times a year, you send it out 4 times a year, that's a significant reduction. The systems need to also be improved. I implemented a zero waste program at AstraZeneca with the elimination of single-use plastics in the office space. That ended up with us having a conversation with Coke and Pepsi, and we got rid of the plastic bottles, and then we started to see these 8-ounce, 12, 20-ounce cans. But then when you stop at the gas station, they then had the 20-ounce cans, and people were buying the cans over the bottles because they understood that the bottles weren't getting recycled, and an aluminum can become an aluminum can in infinity, as opposed to a plastic bottle that can't. And you're spot on. The response, I don't want to have a conversation with 8 billion people on the planet that you need to recycle that bottle that you can't recycle properly. I want to go to Coca-Cola and be like, how do we design this bottle so that it does not persist in the environment? Been all around the planet. I can tell you something I've seen everywhere is a bottle of Coke. It's actually what I use when I travel. Like $1 will be 100 pesos, and I know like a Coke here is $1.50, and a Coke is 25 pesos. So then I'm like, oh, hey, I now know that dinner here is $20, so that I know like dinners should not be more than like 500 pesos. So like, it's a pervasive product, and it's really great to have a conversation. I'm going to keep going, but I agree with you, and I think we can have those supplier conversations. So this digs a little bit deeper into like what can governments and districts do. And again, it's targets and policies. So it's like looking at like it's the assessment, it's the planning and development, it's again renewables. How do we generate more cleaner technology, the circular economy, and then also how do we do this equitably? It's building efficiency, waste management, urban greening, smart grid, industry and innovation, and really policy. And all of these entities here, the Paris Agreement we've talked about, C40 cities, there's a lot more than 40 cities now, and local governments. There's ways that local government can network, connect, exchange ideas. I thought that City Light would appreciate this slide. I found that Puget Sound Energy does an assessment every 10 years looking ahead at what their energy demand is going to be. In 2022, they did a 10-year look ahead and they said, we need 400 megawatts of capacity looking forward. In 2024, they did their assessment and they said, we need 1,825 megawatts of capacity. That's not all AI driven. Some of that is from building electrification and also the increasing in EV. So there is an escalating demand for electricity in our grid, which requires us to get more efficient. Seattle is not the only one that's looking at this. Minneapolis has had a working session. As you can see, this was very handwritten, which I thought was fun. You can see that land use, city values, housing, transportation, these are all elements that pertain to what people are thinking about, how they feel, how they're interacting with their local environment. All of that is really important on how they come together. New York City is actually making headway. They banned all clear story high rises. So you can't have an all glass tall building. I think we lost our architect, but it's really cool to see that changing. Post pandemic, I think I was at New York Climate Week. 51% of commercial office space nationally is empty. And I think, somebody can fact check me on this, but I think it's about 60% of commercial office space in downtown Seattle is empty. And that B-class, C-class office space that's empty, let's renovate it. Let's put in, you don't have to make it all residential. Yes, there's challenges with this, but then you densify your population in these amazing dense population centers. The rooftops, you're gonna have great views, put a bar up there, call it Sunset Bar. But reimagining what these cities can look like, enhancing the building envelope will save energy. Here is, potential reduction is 25 to 50% per building through the new initiatives that New York City put forward. It's something to think about in the urban environment. I worked with DC government for almost 7 years, and we increased the tree canopy by 2% within a 5-year period, which is huge. Seattle's actually been losing part of its percent tree canopy, even though it has a projected growth. But Washington, D.C. has had a really good program. They've had a really great way of planting trees. And I just want to highlight that there are examples that are working. It is scalable. It reduces energy costs in the millions of dollars. I mean, this is only a 64 square mile city. And you're talking about almost $100,000 in avoided carbon emissions as a result of it, and the absorption of carbon. So they're those nature-based solutions are huge. Not only that, everybody likes the Emerald City being the Emerald City. University of Washington has a strategy. Again, energy efficiency. They've converted steam to hot water for their heating of their buildings. They have central cooling. so that like they're cooling all the buildings on campus from a central plant. They're electrifying their heating. That's a little tricky because they are using natural gas. And they have some really old boilers in that building. But they're also, because they're using like a combined heat and power unit where you are burning natural gas on site, is 3 times more efficient than if you're using a natural gas plant from the utility, because you end up with all of that loss in electricity. So it is a net carbon reduction for the electricity that you're consuming, but it's still emitting carbon in the atmosphere. They're continually looking at emerging technology and heat pumps and getting more efficient. But it's a plan, it's a strategy. It takes time, but they're doing what they can along the way. Infrastructure is a huge part of it. Biking infrastructure, especially here in Seattle, it's improving. It's great. E-bikes would be huge. It'd be great to have like covered e-bikes that we could use. And that way people could, because it's never really that cold here. It's freezing rarely in the city. So it's just wet. So having covered e-bikes, but other cities have had a lot of success with, especially in Europe, which is not dissimilar to our weather or climate, where they have heated bike lanes, snow plow for the bike lanes, etc., proper drainage. And Copenhagen is a great example of a city that's being successful with bike infrastructure. And it's just such a huge opportunity. Renewables. Another hot take is, I mean, this is a telephone. It's not, whoop, right? Everybody remembers those old telephones, maybe some of us. But like, as much as telephones have improved, nuclear technology has improved. With the new thermal reactors, they're smaller. One of the companies is actually taking the old nuclear weapons material and using that as feedstock for nuclear power, which is awesome. So we're taking a thing that was destructive and using it to mitigate climate change. In addition to that, you don't, like 3 Mile Island, you don't have this radioactive release because the technology has improved. So when or if it fails, it air cools. It doesn't need to be water cooled. So you don't have that radioactive release. So the things that were a concern before Chernobyl, 3 Mile Island, they don't exist in the new technology. Just like the rotary getting stuck and you not being able to dial out isn't an issue on this phone. It's just not an issue. So nuclear is a carbon-free energy source that could provide a lot of base load. And so we have emerging technology that can help us transition off of fossil fuels faster. Again, the circular economy, thinking about how we can produce and reuse things locally is huge. Amsterdam has done a really good job of this. Copenhagen, again, Slovenia, Seoul in South Korea has it. It's Barcelona in Spain, Tokyo. There's a whole bunch of places. This is not unique. This is not a new concept. Circular. San Francisco has went zero waste by 2020. That was their goal. There is a lot of circular economy. Things can be manufactured locally. You could thermally gasify the waste coming out of the city. When you do that, the materials coming out of it could be broken down into ethane. That's what we make plastics out of. You could have plastics manufacturing, but because then it's all happening with an enclosed loop system in and around the city, you then have this circular economy and can start to support and create local businesses. There's the local food movement, sustainable food, if you can shop at a local farmer's market. But it's about thinking about what is local, what can we eat locally, how can we incorporate regenerative agriculture. Cows are part of the methane emission, a part of our methane emissions. And cows are also one of the best ways to regrow the biome in the soil. Their waste has so many nutrients that they can help regrow and bring the biome and the mycelium back to the soil, which improves crop yields and nutrient density, which has been waning in our crops. And a big part of that is how we've had commercial agriculture and different ways to incentivize these regenerative agriculture is huge. It's a huge opportunity. It's happening in Colombia. It's happening in Eco Village in Ithaca, New York. It's happening in Germany and a couple different places. And there's some really innovative solutions like microloans. This has been one of the biggest hallmarks in India. They put together a group of women, they give them a loan, and then all of them are responsible to ensure that all of them are successful in their business enterprise. It has been, the Grameen Bank has been one of the most successful ways of pushing entrepreneurship and getting people to come to the market. I think that is super successful. The Department of Energy and the Environmental Protection Agency here has done a fantastic job of funding startups to really move the needle. And then, by having this flow and thinking through how we can reimagine our districts, we can be a lot more resilient, being able to produce food locally, which shores up our supply chains. It incorporates this green infrastructure. If we put on and enhance the building envelopes of the city and downtown and enhance the biking infrastructure with e-bikes that people can plug in, people can navigate around the city in a sustainable way with better public transportation. And then people are healthier and more active even the park system that was originally structured, it was about getting people into nature. And there's a lot of studies that are done just by having that break from the urban environment, being able to go to the parks, it's positive. And so bringing back these relationships that we had in our cities to nature, nature to cities, we can build a much stronger city that really thinks through how to bring in that circular economy, build up local industry, agriculture, biodiversity. There is a massive opportunity in this space. I will take some questions on districts.
A question online back to biochar. Megan was thinking that she'd heard of it being implemented on a small scale and that the production of it caused some pretty bad emissions. So is that true? I mean, what's being done already that's not that bad?
Yeah, biochar is being scaled up in a lot of different places. There's different methods. There's an enclosed kiln. There's also those smokeless pits that you've seen in your backyard where you don't get as much smoke from the fire pit. It's a version of that where they're actually doing this on the east side of the Cascades right now, where they are doing biochar to reduce the fuel for fires. And you're not smoking out your neighbors because it's smokeless. They're doing the same thing, and they've gotten permission in Sonoma County in wine country that they can burn the old grapevines through a biochar method. But they can do it almost any time of the year because it's not creating smoke, which was creating poor air quality, which was also impacting the grapes. So biochar does not have the emissions. I don't know, that technology is improved, and it is a really strong solution for some problems, and it actually reduces emissions when done properly because you're combusting everything in the heat and you don't have the emissions.
All right, thank you.
Yeah, no worries.
That's what we have here. Anybody else in the audience? I know we're past 11:30 and I want to recognize that. Thank you for sticking with us. We got, I know, a little bit of a slow start. So, and then just a reminder to folks online, well, and you too. This was recorded, and so we'll have this online if you need to split, so you can see the rest of it.
A quick reminder to do the Slido poll, and the password for that is EOGNMM. That's EOGNMM. Thank you for taking the time to do that. I'd like to thank Mike for his presentation, examples of how it can be done, and considerations to think about. I'd also thank you for being here and participating, both online and in person. We hope you found this topic useful and informative. And if there are other topics you would like to hear about, please make comments in the Slido poll or places. Look forward to seeing you at another one of our sessions in the future. Goodbye for now.
Thanks, everyone.
Thank you, everyone. I'm going to close you online, people. There'll be a poll for you. You don't need to worry about the Slido poll. There'll be a poll for you that pops up in your browser window. Thank you very much.